Hi everyone. So today we're gonna talk about matrices, and in this exercise we have a matrix A, which is this, and we need to find A inverse, and then we need to show that A times A inverse would give me the identity matrix. Now, to find the inverse of A, there are two methods we can use to find the inverse, but let's use the first method. Then I'm gonna talk about the second method in another video. So method 1, we can use the formula of the inverse. So we have A inverse is equal to 1 over the determinant of A times the adjoint of A. So this formula, let's put it here, and we're gonna use this formula to find the inverse of A, right? Now, how can we find the determinant of A? Let's first find the determinant and then we find the adjoint. So determinant of A would be equal to, we take the first here with a positive sign, so plus 2. We multiply it by the determinant of this. When we hide this and this, we would remain with this matrix, right? So we multiply by this determinant, so 6, 7, 9, 1. Then we put a minus. We take the second number, which is the second row, the second column, first row, second column, which is in this case 3. We put 3 here, and then we do the same. We hide this, so we're gonna be left with 5, 7, 8, 1, right? So multiply by 5, 7, 8, 1. We do the same for the last, but this time with a positive sign. So we put plus 4, and then we hide this and this, so we have this. So multiply by 5, 6, 8, 9. Now this would be equal to, this is basically a determinant. So how we're gonna do it, we're gonna multiply this, then we're gonna subtract the multiplication of this. So this would give me 2 times 6 times 1 would give me 6, minus 9 times 7, 63. Then we put minus 3 times, we multiply 5 by 1, so 5 minus 8 times 7, 56. Then plus 4 times 5 times 9, 45, minus 8 times 6, 48. That would give me 2 times, this would become negative 57, minus 3 times negative as well 51, plus 4 times negative again 3. Right, this would be equal to minus 114. Then negative times negative would give me a positive, so we have 3 times 1 would give me 3, 3 times 5 would give me 15. Then here we have a negative 12. Now this would be equal to 153 minus 126. and that would give 30 minus 3, 27. So the determinant of A is 27, right? So we have this one. Now we need to find the adjoint of A, right? So let's copy A here. So that we can see it. So A is here. We want to find the adjoint of A. Adjoint of A would be equal to, then in the first row, first column, we're gonna put this, the determinant. So a plus sign, then we put 6, 7, 9, 1. So this is the first row, first column. Now first row, second column would be a negative, then we hide this and this, so 5, 7, 8, 1. 5, 7, 8, 1. Then a positive sign, we hide this and this, 5, 6, 8, 9. 5, 6, 8, 9. 5, 6, 8, 9. Then don't forget that we need to transpose this. So then we go to second row, first column, which is this 5. So what we need to hide is this and this. We're going to be left with 3, 4, 9, 1. So we put negative 3, 4, 9, 1. Then we put positive. Okay, let's put everything, then negative. Then lastly, okay, we have positive, then negative, then positive. All right, we are in second row, second column, so we need to hide this and this. We're gonna be left with 2, 4, 8, 1. So we write 2, 4, 8, 1, and this one, second row, third column, we have this, so we hide this and this. We're gonna be left with 2, 3, 8, 9. 2, 3, 8, 9. 2, 3, 8, 9. Now third row, first column, we have the 8, so we hide this and this. So we're gonna be left with 3, 4, 6, 7. 3, 4, 6, 7. Then this one, we're gonna be left with 2, 4, 5, 7. 2, 4, 5, 7. And lastly, third row, third column, so the 1, 2, 3, 5, 6. 2, 3, 5, 6. Now this would be equal to we have, this is a determinant, so we multiply 6 by 1, then we subtract 9 times 7. So 6 times 1, let's put, okay, 6 times 1, 6, 9 times 7, 63. Then we put minus here, 5 times 1 is 5, 8 times 7 is 56. then plus 5 times 9 is 45, then 48, minus 8 times 6. We don't have to forget the transpose that we're going to do at the end. Then we put minus 3 times 1 is 3, 9 times 4, 36. Then we put plus 2 times 1 is 2, 8 times 4 is 32. Then minus here 18 minus 24. Then here we have a plus 3 times 7 is 21, minus 6 times 4 is 24. 6 times 4, yeah. Then we put minus here 14 minus 20. Then we put plus 12 minus 15. This would be equal to here we have minus 57. Here we have for the first row, second column, we have a minus, but then inside would be negative, so plus 51. Then here we have a negative, so minus 3. Don't forget the transpose. Then here we have a negative, but inside is negative, so we have a positive. 3 minus 36. Here we have 33. Then here we have a negative 30. Then here we have a negative outside, but inside is negative, so we would end up with a positive. And then 18 minus 24. Then here we have a positive 3. And then we have a negative, but inside is negative, so we have positive 6. Then here we have a negative 3. Now we have a transpose, so by transposing, this would be on the vertical, right? So this would give me minus 57, then plus 51, then minus 3. So all the horizontals are going to be written in vertical. We do the same here. So 33 minus 30, then 6. Here we have minus 3, 6, minus 3. Now this is the adjoint of the matrix A. Now we have the determinant and we have the adjoint, so we can use this formula. We can use our formula. Let's paste it here. So A inverse is equal to 1 over the determinant of A that we have found here, which is 27. 1 over the determinant of A times the adjoint of A, which is this matrix here. Now this is the inverse. Now we need to multiply this one by every number in the matrix. So this would give me as minus 57 over 27. Then we have 33 over 27. Then we have minus 3 over 27. Then we have 51 over 27 minus 30 over 27, 6 over 27. Then we have minus 3 over 27, 6 over 27 minus 3 over 27. Now this would give me, if we try to simplify here, 57 is divisible by 3, 27 as well. So 57 divided by 3 would give me 19, I think. Then 27 divided by 3 would give me 9. Then 33 divided by 3 would give me 11. 27 divided by 3 would give me 9. 3 divided by 3 would give me 1. Then 27 divided by 3 would give me 9. The second row, we would have 19 over 9. Actually, no, this is 51, so 17 over 9. Then we have 30 divided by 3 would give me 10. 27 divided by 3 would give me 9. Then here 6 divided by 3 would give me 2. Then 27 divided by 3 would give me 9. Then we have minus 3 divided by 3, 1. 27 divided by 3 would give me 9. 6 divided by 3 would give me 2. 27 divided by 3 would give me 9. And then minus 1 over 9. So basically, this is the inverse of A. So this is A inverse. Now, what we needed to show, so as you can see, we have found the inverse of A, but we are not quite sure yet if it's correct, because we might have done some mistake in between. But to verify that, if we show that A times A inverse would give me the identity, then it means that we have found the inverse of A. Now let's try to do A times A inverse. Let's see if we're gonna get the identity matrix, which is a matrix where the diagonal are all ones and everything else is 0. So A times A inverse, right? So A times A inverse would be, let's copy A, which is this matrix. This is A. We multiply it by A inverse. A inverse is the matrix we have just found. Here we have a negative. Yeah. Yeah, all correct. Now let's see. So if we multiply this these two, what we are expecting is to get in the diagonal 1 and everything else would give me 0. Now to multiply this, we would multiply this by this, so we can actually use the calculator, and we are expecting to get 1 when we do the first operation, which is 2 times minus 19 over 9. So we first do this times this plus this times this plus this times this to get the first row, first column. So we got 2 times minus 19 over 9 plus 3 times 17 over 9. Then we got plus 4 times minus 1 over 9. If we use the calculator to be quicker, because we are expecting to get 1, so we have 2 that give us 1 as we expected. So we have the first row, first column is 1. Now we are expecting the second row, the first row, second column to be 0. Down first. So we got 2 times 11 over 9, then plus 3 times minus 10 over 9, then we got plus 4 times 2 over 9. So that we expect it to be 0. So this one, let's do it manually. So we got 22 over 9, then we have minus 30 over 9, then we have plus 8 over 9. So we can see that if we add 22 and 8 would give me 30, 30 minus 30 would give me 0. So it is 0 as we expected. So this one give me 0. Let's write it down in black. And then if we do this times this, we would get 0 as well. You can try yourself, and basically we would end up getting something like this, which is the identity matrix. Right, now let's verify correctly. So we have done this one, this one. Now let's do the third one. So if we do this, we multiply by this, so we're gonna have
2 times minus 19 over 9 plus 3, no, actually 2 times minus 1 over 9, because we do this and this. So 2 times minus 1 over 9 plus 3 times 2 over 9, then plus 4 times minus 1 over 9. That would give me what? That would give me 2. So minus 2 over 9. Then we have plus 6 over 9. Then we have minus 4 over 9, which is 0, because this times this plus this will give me minus 6 plus 6, which is 0. So this one is fine. Now here we would expect 0 as well. So we do this and this, which is 5 times minus 19 over 9. Then we have plus 6 times 17 over 9. Then plus 7 times minus 1 over 9. That would give me minus 95 over 9. Then we have plus 6, actually 2, 4, 6 times 1 plus 4, 10 over 9. Then a negative sign here, so minus 7 over 9. We can see that 95 plus 7 would give me 102. So negative 102 plus 102 would give me 0. Right, so this one is correct as well. this one is fine. Now this, we do this and this, which is 5 times 11 over 9, plus 6 times minus 10 over 9, then plus 7 times 2 over 9. That would give me 55 over 9. Then we got negative 60 over 9. Then we got plus 14 over 9. And that is basically 0. That should give me, alright. We got this plus this, which is 69. Yes, which is 69 minus 60, which is 9. And then we got, okay, basically we got 9 over 9, which is 1. So this one is 1, which is correct. And we got the last one, we're expecting to get 0. So what we're going to do is this and this. So we got 5 times minus 1 over 9. Then we got plus 6 times 2 over 9. Then plus 7 times minus 1 over 9. And that would give me minus 5 over 9. Then plus 12 over 9. Then minus 7 over 9. And that is 0. Because we got negative 12 plus positive 12, which is 0. So this one is fine. And the last one
would be fine as well. You can try yourself. You would get 0, 0, 1 for the last column. And this is the identity matrix, which is I. So in summary, what we have done is we have found A inverse, which is by using this formula, which is 1 over determinant of A times the adjoint of A. First we have found the determinant, which was 7. Then we have found the adjoint, which is a bit longer, but we have found the adjoint here. Then we used our formula, which is this, and we have found the inverse. Then lastly we had to show that A times A inverse is the identity matrix, which is a matrix where all the diagonal is 1 and everything else is 0. So we have done the multiplication of A and A inverse, which is this a matrix, which is the identity matrix.